Okay, in this lesson, we shall be looking at aspects of integration and mathematics that is studied in a wide range of areas, but also we shall look at applications of mathematics. Okay. Evaluate the following definite integral. We want to evaluate the definite integral. How to evaluate this definite integral? To evaluate this definite integral, there are a couple of things that we're going to do. And so we're going to use, there is a rule that we're going to use. Right, and this rule says that the integral of x to the power n dx is 1 over n plus 1 x to the power n plus 1 plus c under one condition, that n is different from minus 1. Right, so the integral of 6 is clearly 6x, and then we put minus 4x. Now the x to the power 1, so that we add 1 and 1, we get 2 out of 2. And this integration is carried from minus 1 to 2. We substitute the limits of integration, getting 6 times 2 minus 4, 2 squared out of 2. Right, and we can put this in parentheses like so, minus the 6 times minus 1 minus 4 minus 1 squared over 2. Okay, so yeah, just take note of that, and we proceed with ease. Right, so we then have that this is 12 minus. Right, so you divide here, which is 2 by 4, which is 8, minus 6. And this here is a 1, and this here divided by the 2, which becomes minus 2. So that's what you have here. This is a minus 1 that comes from the limit of integration. And the 12 minus 8 is actually a 4 plus 8. And 4 plus 8 is exactly 12. And the correct option here is actually 12, which means therefore this integral here is equal to what? Is equal to 12, exactly. Okay, we practice now with the next question. Right, you want to determine the following indefinite integral, and this integral here. Right, and this integral here is a very, very important one. And how do we then proceed to deal with this one? We look at the fact that it is an indefinite integral. Indefinite integral means that it has no limits of integration. No limits of integration. Right, multiply through x by x squared, we get x cubed plus twice x, like so. So we perform multiplication that way, and this is what we're able to get. And this is dx, which means that it is x to the 4. Now this one here you can write like this: plus 1 over 3 plus 1 plus 2x to the power 1, which is 1 plus 1 divided by 1 plus 1. And then you add the arbitrary constant of integration c. 3 plus 1 it's a 4, so that we have x to the 4th power over 4 minus this is 2 over 2. X squared plus c. Right, and therefore this is the answer. Okay, this is the answer. Right, so obviously take note of the fact that this one here is a plus, so that you have a plus there. And you have to go through the options that have been given. And going through the options that have been given, you check very, very carefully, and you can see which option this is. It appears to be the first option. It looks like it is the first option because the others are incorrect. Any question? No. No question. Next one. Okay, so we've already seen that this one is actually done, and the answer is x to the fourth power, x to the fourth power over 4 plus x squared plus c. Right, so this is plus x squared plus c. Right, so now we have this one here, which means we have x. Now, at this point, x times x squared is x cubed. X times minus the square root is minus x times the square root of x, which is actually x cubed, x times x to the 1/2. That means that to the power 1, the bases are the same. You multiply these two powers, you add the exponents. This x cubed is carried forward, minus x to the power 3 over 2. Right, so if y is x cubed, x to the power 3 over 2, we find dy dx. You bring down the 3. Because we're using calculus, finding dy dx. Bring down the 3 gives us 3x squared minus, bring down the 3 over 2 here, x to the power. We have 3 over 2 minus 1, which is only 1/2. Upon careful examination, this is 3x squared minus 3 over 2, the square root of x. Right, so now you think of which one is the correct one. You can see that option 3 has the 3x squared and has minus 3 over 2 times the square root of x as well. Right, so we have seen the answer to this one. Now we look at the next question, and the next question is about demand functions and supply. A demand function for a firm is given as Q equals 150 minus 0.5 P, where P and Q represent the quantity and price respectively. At what value of P is the marginal revenue of the firm equal to 0? Right, first we find the revenue. What is the revenue? Right, so in other words, we're able to see that revenue is price multiplied by quantity. So that revenue is the price times the quantity. What is the quantity? Is 150 minus 0.5 P. So that revenue is equal to 150 P minus 0.5. P times P is P squared. Okay, so we multiply this with this and you multiply this with that. Right, so if we're to call the revenue R, for example, we can be able to find then, because they're saying, at what value of P is the marginal revenue of the firm equal to 0? So we need to find the marginal revenue. So this one is the revenue. And then what is the marginal revenue? We find it. Marginal revenue is the derivative of this one with respect to P, which is 150 minus 0.5 times 2 P. Okay, so the marginal revenue of the firm equals 0, which means therefore you have 150 minus P equals 0, and P equals 150. So the question was, at what value of P is the marginal revenue of the firm equal to 0? So we can see that the marginal revenue, so this quantity here is the derivative, and the derivative is marginal revenue. Right, and this marginal revenue equal to 0 here. Equals 0. Okay. Okay, we continue. We continue and we do the next one.
Yes.
Right, so yeah, we've already done this demand function, and yeah, we solved this one. Now find the values of x for which this function has a minimum or maximum value. So for the minimum or maximum, we note the function first. For the minimum or maximum, we note the function first, which is x plus 3x squared. Okay, so yeah, you can find, you can use the prime notation for the derivative, so that we have f primed, because we need the minimum or maximum, so we find the derivative, which is 3x squared plus 6x. Okay, so because we want to find the values of x for which this function has a minimum or maximum, we equate to 0 for minimum or the maximum. We factor out 2x out of this. X equals 0. 3x times x is 3x squared. 3x times 2 is 6x. Getting x equals 0 out of this, x equals minus 2. So these are the two answers. So we need x equals 0, x equals minus 2. So in other words, the correct option would be option 1 there. Next question. Find the values of x. So yeah, this is the question we just did, and we've got the answer to it. The cost y. Okay, so we're dealing with the cost y of manufacturing x bicycles is this one here. How many bicycles have been manufactured? If the cost is this. Okay, let's look at the cost. 240x plus 720. So the cost y of manufacturing x bicycles is that one. That is the cost of manufacturing x bicycles. And it is exactly that. So how many bicycles have been manufactured if the cost is 30,000? Okay, so in other words, we know that the cost, what is the cost? The cost is 30,000. So, and the cost y, so which means that y equals 30,000. Which means at this point, when I have 30,000, is 240x plus 720. Okay. So we want to know how many bicycles have been manufactured. So we're dealing with x is the number of the bicycles. So we need to solve for x. So the question is saying, what is x, the number of the bicycles? So we're going to take 30,000 minus 720 equals 240. Like this. Which means, therefore, you have 30,000 minus 720. 30,000. Yes, it is exactly 29,280. Is that what you have as well? Which is 240x. And I want to find x, so we say 29,280, we divide by 240, and this is 240. X, we divide by 240, and we simplify everything here, canceling these two guys so that x equals
122.
What answer do you have here?
122.
All right, so yeah, I'm also checking to make sure that we have the correct answers here that are needed. So we divide by 240. And you have 122.
Yes.
And it appears, therefore, that our option is what? It's option 2. 122 bicycles. Because the question was, how many bicycles have been manufactured if the cost is what? 30,000 altogether. Next, now we attempt to solve this question in different ways, and we solve this particular question. The next one. Right, in the next case, we have already solved this one on the bicycles, so we're excited about the bicycles. A company has a total fixed cost of 560,000. So it is the fixed cost. The variable cost is 9,000 per unit. If 140 units are produced, what is the total cost? Okay, so let's look at this particular question. So we're interested in the total cost. The total cost is to do with the variable cost of 9,000 plus 560,000. Okay, so we have 140 units, which is exactly 9,000 into 140 plus 560,000, which means therefore, if you have 9,000 times 140 plus 560,000, let's see what the answer is to this one here. 9,000. Okay, so we have 9,000 times 140 plus 560,000.
Yes, 182. 1,860,000.
Right, so it sounds like it is 182. And then it is also, yeah, let me write it properly. Right, so we can write here the 82. So 1, then 820, and then 3 zeros like this. Okay, it's sort of what it is, right? So it's 1820, then 3 zeros. So which option is it?
Option 2.
It's option 2. Thank you so much. Thank you so much. We've already done this question. We need to solve the following linear system of equations. So how do we solve this system of equations?
Partial derivative.
Please come again.
Partial derivative.
All right. Okay, so this is how we need to solve it. So we first write the coefficient matrix x, y, z.
Oh, matrix.
Yes, or we can use other methods, but yeah, this one is the best. Then we're gonna have here 1 minus 2, 3, 0, 2 minus 1, 0, 3, 1.
Why is it 0?
Oh, why is it 0? Yeah, that's it. Okay, because the x is 2. Let me check here. Okay, let's talk about this. Okay, because x is 2 and then y is 0 here. But, okay, so obviously at this point, I mean, this can be written as, okay, yeah, let's write it as follows. Okay, it has to be written as, okay, let's look at the x term. So it's 1x minus 2y plus 3z equals minus 1. Okay, now we have 2x plus 0y minus z equals 8. And then we have 0x, 3y plus z equals 10, like this. Okay, let's look at this now. Okay, because we are just making sure that the x's are together, you know, because there's like a single x, and then here this one is x, 2x, and then the bottom one has no x term. Now this one is minus 2y, but the second equation does not have a y term, so it is 0y, and then the bottom one has 3y. And then now this one is 3z, and then you have minus z, and then plus z. Okay, we have minus 11, 8, and 10. Okay, so this one is ax equals b. Ax equals what? It's of the form ax equals b. Okay, we want to solve this system. Right, to solve this system, there are a couple of things we need to consider. But what do we consider? Right, so we're going to consider the fact that we need to find the inverse of this matrix. Right, so we're dealing with what we call the inverse matrix. Right, to deal with the inverse matrix, we take the matrix here, 2, 0, minus 1. Oops, okay, yeah. Okay, I'm going to be offline for a couple of minutes, a second. See now. Right, yeah, Cooper, green button, please.